Water, the unsung hero of chemistry, embodies a paradox that defines its very essence. Are you ready for a challenge? Here's a brain teaser for you. That's a little bit easy. Let's try another one. Have you guessed it? The answer is base.
Water. Water is unique in a way that it can act as both an acid and a base, otherwise called amphiprotic. It has the unique ability to combine and act as an acid and a base in a process called autoionization. In the property of water as a base, it accepts a hydrogen ion when mixed with a stronger acid.
A substance that can either donate or accept a proton depending on the circumstances is called amphiprotic compound. And this process of donating and accepting protons is called the autoionization of water. The equilibrium expression for this reaction is Kw equals H3O plus OH minus, where Kw is the autoionization constant for water. At 25 degrees Celsius, the value of Kw is 1.0 times 10 raised to the power of negative 14.
Ion product. The ion product of water has the equation of Kw equals H30 plus and OH minus, and has the value of 1.0 times 10 raised to the power of negative 14 mole to liter negative 2 at 25 degrees Celsius, but it is strongly temperature dependent, becoming 1.0 times 10 raised to the power of negative 15 at 0 degrees Celsius, and 7 times 10 raised to the power of negative 13 at 100 degrees Celsius. In principle, the value of Kw can be determined by measuring the electrical conductance of very pure water, in which H3O plus equals OH minus equals 107 at 25 degrees Celsius. But in practice, it is derived from other measurements. For example, measurements of the degree of hydrolysis of salt.
Practice problems. Calculate the concentration of H plus in a solution in which OH negative is 0.010 moles. In this problem, the temperature is 25 degrees Celsius. H plus equals Kw over OH negative, where Kw has constant value of 1.0 times 10 raised to the power of negative 14, and as the given show, OH negative has value of 0.10 mole. When we divide it, we can have the value of 1.10 raised to the power of negative 12 mole.
The first example of real-life application of acid-based property of water is the theory of that acid is a substance that can release a proton, and a base is a substance that can accept a proton. It also emphasizes the hydrochloric acid in your stomach. The acid will completely ionize in the water, and there is a formation of hydromium ions and chlorine ions. In the second example, water behaves as acid in one instance and can function as bases in the other. Such substances which can serve in either capacity, depending on the condition, are said to be amphiprotic.